wiring arrangement appears to be incorrect and potentially unsafe. Issues with the circuit breaker include improper amperage, where a 20 amp circuit breaker should not be used with 10 American wire gauge wire, which is rated for 30 amps. This could result in overheating and fire hazards. Also, the label is misleading. For example, the A/C spare label is misleading. The 15 amp circuit breaker should not be used for an air conditioner. Issues with the jumper wire include improper gauge, where the 12 American wire gauge jumper wire is too small for the 10 American wire gauge circuit it is connected to. This could create a voltage drop and potential overheating. Also, there is a lack of protection, where the 12 American wire gauge jumper wire is not protected by a circuit breaker. If it fails, it could cause a short circuit and electrical fire. Potential consequences include electrical fire, where overheating in the wiring or circuit breaker could lead to an electrical fire. Also, there is equipment damage, where improperly sized wiring could damage air conditioners or other heating, ventilation, and air conditioning equipment. Furthermore, there could be shock or electrocution. If the jumper wire fails, it could create a dangerous shock hazard. As a recommendation, it is essential to have a qualified electrician evaluate this situation and make necessary corrections. 20 amp circuit breaker and 12 American wire gauge jumper wire should be replaced with appropriately sized components that meet the requirements of the wiring and equipment being used. An electrical inspection by a licensed electrician is recommended to ensure the entire electrical system is safe and up to code. It is important to note that electrical work should always be performed by qualified professionals to ensure safety and compliance with building codes. Firstly, the use of a 20 amp circuit breaker with 10 American wire gauge wire is problematic because 10 American wire gauge wire is designed to handle 30 amps. Using a 20 amps breaker on a wire capable of handling more current doesn't inherently create an immediate hazard, but it defeats the purpose of circuit protection. The circuit breaker is intended to protect the wire from overheating due to overcurrent. If the wire is rated for 30 amps but protected by a 20 amps breaker, the breaker will trip before the wire is ever in danger of overheating. This might seem safe, but it indicates a misunderstanding of circuit protection principles. Secondly, the A/C spare label being associated with a 15 amp circuit breaker is concerning. Air conditioning units typically require a dedicated circuit with a high amperage rating, often 20 amps or more, depending on the size and electrical requirements of the air conditioner. Using a 15 amps breaker for an air conditioner could lead to nuisance tripping, meaning the breaker trips frequently due to the air conditioner drawing more current than the breaker is rated for. This is not only inconvenient, but can also damage the air conditioning unit over time. Thirdly, the use of a 12 American wire gauge jumper wire in a circuit with 10 American wire gauge wire presents several issues. The 12 American wire gauge wire is smaller in diameter and has a lower current carrying capacity than the 10 American wire gauge wire. When a smaller gauge wire is used in a circuit with a larger gauge wire, it becomes a weak point in the circuit. The smaller wire can overheat if the circuit draws more current than it can safely handle, potentially leading to a fire. The fact that the 12 American wire gauge jumper wire is not protected by a circuit breaker exacerbates the problem. Without a breaker, the wire is not protected from overcurrent and can easily overheat and fail. This is a significant fire hazard. A voltage drop can occur when the current flowing through a wire causes a reduction in voltage along the length of the wire. This is more pronounced in smaller gauge wires and longer runs. While a short jumper wire might not cause a significant voltage drop, it's still not an ideal practice to mix wire gauges in a circuit. If the jumper wire fails, it can create a dangerous shock hazard. If the insulation on the wire is damaged and a person comes into contact with the exposed wire, they could receive an electrical shock. This is especially dangerous if the person is grounded or in contact with water. It is crucial to have a qualified electrician evaluate the situation and make necessary corrections. This includes replacing the 20 amp circuit breaker with one that is appropriate for the load and the wire gauge. The 12 American wire gauge jumper wire should be replaced with a 10 American wire gauge wire to match the rest of the circuit. It is recommended that a licensed electrician perform an electrical inspection to ensure that the entire electrical system is safe and up to code. This will help identify any other potential hazards and ensure that the electrical system is functioning properly. It is important to note that electrical work should always be performed by qualified professionals to ensure safety and compliance with building codes. Incorrect wiring can lead to serious consequences, including electrical fires, equipment damage, and shock hazards. One must understand the principles of electrical wiring and circuit protection to ensure safety and prevent potential hazards. The American wire gauge, abbreviated as American wire gauge, is a standardized wire gauge system used predominantly in the United States for the diameters of round, solid, non-ferrous, electrically conducting wire. The larger the American wire gauge number, the smaller the wire. Increasing gauge numbers correspond to decreasing wire diameters. This relationship comes from the manufacturing processes used to produce wire. Wire is drawn through a series of dies to reduce its diameter. Smaller gauge numbers represent the number of drawing operations used to produce the wire. For example, a 24 American wire gauge wire has gone through 24 drawing operations. American wire gauge is used to specify the diameter of a wire, which in turn determines its current carrying capacity, resistance, and weight. These properties are important for electrical and electronic applications. The current carrying capacity of a wire, also known as ampacity, is the maximum amount of current that a wire can safely carry without overheating. The ampacity of a wire depends on its gauge, material, insulation type, and ambient temperature. The National Electrical Code, or NEC, provides guidelines for the ampacity of different wire gauges and insulation types. It is important to select the appropriate wire gauge for a given application to ensure that the wire can safely carry the required current. The resistance of a wire is a measure of how much it opposes the flow of electric current. The resistance of a wire depends on its length, diameter, material, and temperature. Longer and thinner wires have higher resistance, while shorter and thicker wires have lower resistance. The resistance of a wire is important for calculating voltage drop and power loss in a circuit. Voltage drop is the reduction in voltage along the length of a wire due to its resistance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. Power loss is the amount of electrical power that is dissipated as heat in a wire due to its resistance. Power loss can reduce the efficiency of a circuit and increase energy consumption. The weight of a wire is determined by its material and dimensions. Heavier wires have higher current carrying capacity, but are also more expensive and difficult to work with. The selection of wire gauge involves balancing the need for adequate current carrying capacity with the cost and ease of installation. Circuit breakers are safety devices designed to protect electrical circuits from overcurrents. They work by interrupting the flow of current when it exceeds a predetermined level. Circuit breakers are essential for preventing electrical fires and protecting electrical equipment from damage. Circuit breakers are rated in amps, which indicates the maximum amount of current that they can safely carry without tripping. It is important to select the appropriate circuit breaker rating for a given circuit to ensure that it provides adequate protection. Using a circuit breaker with too low of a rating can cause nuisance tripping, while using a circuit breaker with too high of a rating can allow excessive current to flow, potentially damaging the wiring and equipment. Circuit breakers come in different types, including thermal, magnetic, and electronic. Thermal circuit breakers use a bimetallic strip that bends when heated by excessive current, causing the breaker to trip. Magnetic circuit breakers use an electromagnet that trips the breaker when the current exceeds a certain level. Electronic circuit breakers use electronic circuitry to detect overcurrents and trip the breaker. Jumper wires are short lengths of wire used to make temporary connections between different points in a circuit. Jumper wires are commonly used in prototyping, testing, and troubleshooting electrical circuits. It is important to use jumper wires of the appropriate gauge and insulation type for the application. Using jumper wires that are too small or have inadequate insulation can create a safety hazard. Electrical safety is of paramount importance when working with electrical circuits. It is essential to follow all safety precautions to prevent electrical shocks, burns, and fires. Before working on any electrical circuit, it is important to turn off the power at the circuit breaker. It is also important to use insulated tools and wear appropriate personal protective equipment such as gloves and eye protection. When working with electrical circuits, it is important to be aware of the potential hazards and take steps to mitigate them. This includes avoiding contact with live wires, keeping work areas dry, and using ground fault circuit interrupters or GFCIs in wet locations. Ground fault circuit interrupters are devices that detect ground faults and interrupt the flow of current to prevent electrical shocks. They are required by code in wet locations such as bathrooms, kitchens, and outdoor areas. Electrical codes are sets of regulations that govern the design, installation, and maintenance of electrical systems. Electrical codes are designed to ensure safety and prevent electrical hazards. It is important to comply with all applicable electrical codes when working on electrical systems. The National Electrical Code, or NEC, is the most widely adopted electrical code in the United States. It is published by the National Fire Protection Association, or NFPA, and is updated every 3 years. The National Electrical Code, or NEC, covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It is important to consult the National Electrical Code, or NEC, when designing and installing electrical systems to ensure compliance with safety regulations. Electrical inspections are conducted by qualified electrical inspectors to verify that electrical systems are installed and maintained in accordance with electrical codes. Electrical inspections are typically required for new construction, renovations, and electrical repairs. The purpose of an electrical inspection is to ensure that the electrical system is safe and functioning properly. Electrical inspectors check for compliance with electrical codes, proper wiring methods, and adequate overcurrent protection. If an electrical inspection fails, the homeowner or contractor is required to make the necessary corrections to bring the electrical system into compliance with the code. The process of electrical wiring involves connecting electrical components together to create a functional circuit. Electrical wiring can be done using a variety of methods, including using wires, cables, and conduits. It is important to use the appropriate wiring method for the application and to follow all applicable electrical codes. When wiring electrical circuits, it is important to use the correct wire gauge for the application. The wire gauge should be selected based on the current carrying capacity of the wire and the length of the circuit. It is also important to use the correct type of insulation for the wire. The insulation should be appropriate for the voltage and temperature of the circuit. Grounding is an essential part of electrical safety. Grounding provides a path for fault current to flow back to the source, causing the circuit breaker to trip and de-energize the circuit. Grounding also helps to protect against electrical shocks by providing a low impedance path for current to flow to ground. Electrical equipment should be properly grounded to ensure safety. Grounding can be accomplished by connecting the metal enclosures of the electrical equipment to a grounding electrode, such as a ground rod or a metal water pipe. Overcurrent protection is the use of circuit breakers or fuses to protect electrical circuits from overcurrents. Overcurrent protection is essential for preventing electrical fires and protecting electrical equipment from damage. Circuit breakers and fuses should be sized appropriately for the circuit that they are protecting. They should also be tested regularly to ensure that they are functioning properly. Electrical maintenance is the process of inspecting, testing, and repairing electrical equipment to ensure that it is functioning properly. Electrical maintenance is essential for preventing electrical hazards and extending the life of electrical equipment. Electrical maintenance should be performed by qualified electrical personnel on a regular basis. Electrical troubleshooting is the process of identifying and resolving problems with electrical circuits. Electrical troubleshooting can be challenging, but it is essential for keeping electrical systems running smoothly. Electrical troubleshooting requires a thorough understanding of electrical principles and the ability to use test equipment, such as multimeters and oscilloscopes. The National Electrical Code, or NEC, Table 310.15b16 provides ampacity ratings for various wire sizes based on insulation type and temperature rating. These ratings are based on the assumption that the wire is installed in a raceway or cable and that the ambient temperature is 30 degrees Celsius or 86 degrees Fahrenheit. If the wire is installed in a different environment, the ampacity rating may need to be adjusted. For example, if the wire is installed in free air, it will have a higher ampacity rating than if it is installed in a raceway. The National Electrical Code, or NEC, also provides guidelines for directing wire ampacity when multiple conductors are installed in a single raceway or cable. When multiple conductors are installed together, the heat generated by each conductor can raise the temperature of the other conductors, reducing their ampacity. The directing factors are based on the number of conductors in the raceway or cable and the ambient temperature. The use of a 15-amp circuit breaker labeled as /C spare is a common practice in some homes, but it is not recommended. Air conditioning units typically require a dedicated circuit with a higher amperage rating, often 20 amps or more, depending on the size and electrical requirements of the air conditioner. Using a 15 amps breaker for an air conditioner could lead to nuisance tripping, as the air conditioner may draw more current than the breaker is rated for. This can be inconvenient and may also damage the air conditioning unit over time. It is important to consult the manufacturer's specifications for the air conditioning unit to determine the appropriate circuit breaker size. The use of a jumper wire to connect two different gauge wires is not recommended. A jumper wire is a short length of wire used to make a temporary connection between 2 points in a circuit. Jumper wires are often used for testing or troubleshooting electrical circuits. When using a jumper wire, it is important to use the same gauge wire as the circuit being tested. Using a smaller gauge wire can cause the jumper wire to overheat and potentially melt, creating a fire hazard. It is also important to ensure that the jumper wire is properly insulated to prevent electrical shocks. Electrical work should always be performed by qualified professionals to ensure safety and compliance with building codes. Electrical work can be dangerous if not performed properly, and it is important to take all necessary precautions to prevent electrical shocks, burns, and fires. If you are not comfortable performing electrical work yourself, it is best to hire a qualified electrician. A qualified electrician will have the knowledge, skills, and experience to perform the work safely and correctly. They will also be familiar with the applicable electrical codes and regulations. When hiring an electrician, it is important to check their credentials and ensure that they are licensed and insured. You should also ask for references and check their reviews online. It is also important to get a written estimate before the work begins. The estimate should include a detailed description of the work to be performed, the materials to be used, and the total cost of the project. In addition to the specific issues described, there are a number of other potential electrical hazards in homes. These hazards include frayed or damaged wiring, overloaded circuits, loose connections, and improper grounding. It is important to inspect your home's electrical system regularly to identify and correct any potential hazards. You should also have your electrical system inspected by a qualified electrician every few years to ensure that it is safe and functioning properly. By taking these precautions, you can help to prevent electrical shocks, burns, and fires in your home.